Welcome, ladies and gentlemen, to the first video of Chapter 8, which is Section 1, Graphing Exponential Growth and Decay Functions. Chapter 8 is all about exponential growth and decay and logarithms. Many of you have been asking about logs over the past few months because you've seen it on the ACT, so we're finally going to learn about logs eventually, but today we're going to start with exponential growth and decay. There is one objective for today's video, which you probably could have guessed it. We're going to graph exponential growth and decay functions and their translations. Before we jump into the graphing, we should probably talk about what exactly is an exponential function. So an exponential function is a function where the base is a constant and the exponent is a variable, in this case x. So some examples would be y equals 5 to the power x, or y equals 1/2 to the power x. The base is a constant, so 5 and 1/2, and the exponents are variables, so x and x. Each exponential function, when we're graphing it, is going to have an asymptote. An asymptote is a line that the graph approaches. So it's not actually part of the graph, but it's going to be a horizontal line that's kind of like a boundary. The graph is going to get really close to that boundary, but it's never going to cross it. So we're going to graph two different types of functions today. We're going to graph exponential growth and exponential decay. They have a lot of similarities. First, we're just going to talk about the parent function. The parent function is just the most basic type of exponential growth. So the most basic type of exponential growth is y equals b to the x, and b has to be greater than 1. The most basic type of exponential decay is y equals b to the x, but b is between 0 and 1. So an example of growth would be like y equals 2 to the x. Decay would be y equals 1/5 to the x. 2 is greater than 1, which is why that's growth. 1/5 is between 0 and 1, which is why that's decay. Again, these are just the most basic functions. On the next page, we're going to be shifting them and translating them, moving them around a little bit. The domain for both growth and decay is going to be all real numbers. You can also write the fancy R. The range for the basic parent function is going to be y is greater than 0 for both growth and decay. Once we move around the graph, it's going to change the range a little bit, but for right now it's just y is greater than 0. The asymptote for both is going to be y equals 0. And something to notice is that the range and the asymptote always are going to match. So on the next page, when we move around our asymptote and our range, it's going to move with the graph. Okay, here's the big difference, is in the general graphs. In an exponential growth function, the function is going to start low and then increase rapidly. Whereas in an exponential decay, it's going to start high and then decrease rapidly. So these are just some basic ideas. What we're going to be doing in today's video is we're going to find the asymptote, fill out a table, graph the function, and then find the domain and range. We're going to start with two basic examples before moving on to the more complicated ones. Okay, so on the left we have f of x equals 3 to the x. 3 is greater than 1, so this is going to be a growth function. It's going to start low and end high. First thing that I need to do is find the asymptote. I told you for right now the asymptote is at y equals 0. So this is going to be the line that the graph approaches but does not cross. The way we normally show an asymptote is a dotted line on the graph. Next, we're going to draw a table. For right now, we're going to put 0 in the middle of the table. We're going to go down 2 values, so -1, -2, and up 2 values, 1 and 2. And then start filling in. I'm going to start at the middle of the table. 3 to the 0 power is 1. Remember, anything to the 0 power is always 1. 3 to the first power is 3. 3 to the second power is 9. Now going backwards, 3 to the negative first is not negative 3. 3 to the negative first is 1 over 3 to the first, or 1/3. 3 to the negative second is 1 over 3 squared, so 1/9. And now I'm ready to graph. So I'm going to start with 0, 1, and then I have 1, 3, and then I have 2, 9, which I think is going to go off of our graph just a tiny bit. I have -1 and 1/3, and I have -2 and 1/9. 1/9 is really small, very close to 0, but not exactly 0. And now we're going to draw on our graph. Okay, so first thing to notice is that this is a growth function. We already knew it was growth, so it started low and it ended high. It grew rapidly. So that's good. Before we move on to the next example, we do have to identify the domain and range. So I'm going to do a little erasing. Hopefully you have some room. Okay, the domain is going to be all real numbers. That's always going to be the case. The range in this case is y is greater than 0. We notice 0 is where the graph starts and then it increases. It gets really close to 0, which is the asymptote, but it never crosses it. So this is a growth example. If you look at the example to the right, this is going to be a decay example. The way we know this is because I have 1/3. 1/3 is between 0 and 1, so this is going to be decay. So first thing, let's identify that asymptote again. Again, on these basic examples, it's just going to be y equals 0. Examples on the next page, the asymptote is going to move, and I'm going to show you how that works. But for right now, it's just y equals 0. And now we got to start filling in this table. Again, I'm going to start with 0, go down 2, and go up 2. Starting with 0, 1/3 to the 0 power is just 1. Again, anything to the 0 power is 1. 1/3 to the first power is just 1/3. 1/3 to the second power is 1 squared over 3 squared, which is 1/9. Okay, now 1/3 to the negative first power is 1 to the negative first over 3 to the negative first, which becomes 3 to the first over 1 to the first, so 3. So in essence, it means flip and then take the power. So 1/3 to the negative second, so I'm going to flip 3 over 1, and then I'm going to square it. It becomes 9. And now I'm ready to graph. So I have 0, 1. I have 1, 1/3, 2, 1/9. Remember, 1/9 is really close to 0, but not quite 0. And then I have -1, 3, and I have -2, 9, which again goes off of our graph a little bit. Connecting, I end up with this curve. It looks very similar to the last example, but it's almost like a mirror image. It's like we reversed it. So you'll notice that the graph starts high and ends low. That's because this is a decay function. Decay functions always do that, start high, end low. The last thing that you're going to be asked to do is find the domain and range. The domain is still all real numbers. The range has to do with y. If I look at my graph, I see that y starts at 0 and it increases. So I have y is greater than 0. It's never actually 0. It just gets really close. So these are the most basic exponential growth and decay functions. On the next page, we're going to be taking these functions and moving them around a little bit, moving them up and down, left and right. That's going to change the asymptote and it's going to change the range, but the general process of graphing is the same. So if you would please flip the page. Okay, so now we're going to move on to some more difficult graphing examples. These are called translations. So we're going to take those parent growth and decay graphs that we did on the previous page, and we're just going to move them around a little bit. Move them up, down, left, right. This is the new equation that we're looking at. So we were looking at y equals b to the x. I've added in an a, an h, and a k. Each of those stand for something special. The k now is where the asymptote is. The h is where you're going to start the table. It's going to be the middle x value. And something to note is that it's x minus h. So this is going to be one of those cases where you're going to have to flip the sign. And then the last one is the a. The a is either going to shrink, flip, and or stretch the graph. This is one that you don't really need to worry about. We're going to worry about the h and the k, so the asymptote and then the middle value. Before we look at the first graph, let's look at an example that's like y equals 2 to the x minus 1 plus 4. Okay, so that 4 means that our asymptote is going to be at y equals 4. That minus 1 means that when we do our table, the middle x is going to be a 1. And then we would go down from there. So 0, -1, and then up 2 and 3. So this 1 brings us here. Notice that I flipped the sign. It's x minus 1, but I chose a positive 1. And then the asymptote is that 4, and just keep the sign. So that was just an example. Now we're actually going to graph one. So the example to the right is y equals 2 to the power x, add 1. So this 1 is going to be our asymptote. Okay, so below the graph it says what's the asymptote? Well, our asymptote is y equals 1. Before I forget, I'm going to put that on the graph. Remember that the asymptote is going to be a dotted line. Okay, and then we have 2 to the power x. There's no h, so that means h is 0. So in our table, the middle value, like before, is going to be 0. I'm going to go down 2, so -1, -2, and up to 1, 2. And now I'm ready to substitute in. So I have 2 to the 0 plus 1. 2 to the 0 is just 1. 1 add 1 is going to be 2. I have 2 to the first, add 1. 2 to the first is 2. Add 1 is going to be 3. I have 2 to the second, add 1. 2 to the second is 4. Add 1 is going to give me 5. Now let's do the negatives. 2 to the -1 plus 1. Remember that 2 to the -1 is 1 over 2 to the first power plus 1. So this is 1/2 plus 1, which is 1 and 1/2, or 1.5. And then I have 2 to the -2nd, add 1. This is going to be 1 over 2 squared, add 1. 1 over 2 squared is 1/4, plus 1 is 1 and 1/4, so 1.25. And now I'm ready to graph. I'm going to start with the middle value, the 0, 2. I then have 1, 3, and 2, 5. I have -1, 1.5, and I have -2, 1.25. So it should be really close to the asymptote, but not actually touching it. And then I'm going to connect everything. This is what my graph looks like. Notice that it hugs really close to that asymptote, but it never is going to touch it and it never crosses it. So we need to do a little mental check. Does this graph make sense? Well, the graph starts low and it goes high. So this is indicative of a growth function. Okay, does that make sense? Well, I have 2 to the power x. 2 is greater than 1, which means that this should be growth. I just like to do a little mental check to make sure that my answer makes sense, my graph makes sense. Again, the graph is going low to high, so it's growth, which makes sense because we have 2 to the power x. Since 2 is greater than 1, this should be a growth function. Remember that if the base is between 0 and 1, it should be decay. Last two things we have to do are domain and range. Remember that your domain is going to be all real numbers. And that's because x can be whatever it wants. It's the negatives, the positives. The range is always y. If we look at our graph, we notice that our graph starts at y equals 1 and it increases. So our range then is going to be y is greater than 1. It never is actually 1, it's always a little bit above 1. Another little mental check is your asymptote and range should match. So we have 1 and 1. They're not going to match the equal sign and the greater than, but the numbers should match. Okay, so now we've graphed 3 examples. We've graphed 2 of the basic parent functions, and then we've looked at a graph that moved the asymptote. Now you're going to try one on your own. If you would be so kind as to pause the video and try this example right here on your own, please. I don't want you to try the right example, just the left one. When you are completely finished, come back and we will go over it together. Good luck. Okay, let's see how we did. First thing, this -3 is our asymptote. So our asymptote becomes y equals -3. And then I'm going to put that on my graph. Now I'm going to do the table. Remember that this x plus 2 tells us where to start our table. If you made a mistake, my guess is here was the place you made the mistake. Okay, so we have add 2, but you need to flip the sign. So we should have started our table at -2. If you started it at +2, that would have messed you up. Go down 2, so -3, -4, and up 2, -1, and 0. And now we have to substitute in. I have 1/4, I'm going to start with the -2, to the -2 plus 2 minus 3. So this becomes -4, or 1/4 to the 0 power, which is 1. 1 minus 3 should have been -2. Now with the -1, I have 1/4 to the -1 plus 2 power minus 3. This is 1/4 to the first power minus 3, which is -2.75. I then have 1/4 to the 0 plus 2 power minus 3. So this is 1/4 squared, so 1 over 16 minus 3. This ends up being -2.9375. So you may have needed a calculator for that one. Okay, so now to do the -3. That's 1/4 to the power -3 plus 2 minus 3. So this is 1/4 to the negative first power minus 3. Sorry, I'm kind of running out of room here. I'm going to continue up here. So 1/4 to the negative first power minus 3. This becomes 4 minus 3, which is 1. And then last, I have 1/4 to the -4 plus 2, which is -2 power minus 3. 1/4 to the -2 power means I'm going to flip and then square. So this is 1/4 squared minus 3. I'm sorry. It's exactly the opposite of what I just said. So flip, so 4 squared minus 3. So 16 minus 3 is 13. Okay, so my guess is you probably got at least one of those wrong, which is okay. Sometimes we forget how to work with those exponents. Now we're ready to graph. So I'm going to start with my middle, which is -2, -2. I then have -1, -2.75, and 0, -2.9, so really, really close to -3. I then have -3, +1, and -4, +13, which definitely does not fit on my graph. So connecting. This is what you should have gotten. Yours should look better than mine does. Remember that it's kind of hard to draw on an iPad, so sorry that mine did not turn out so nicely. But this is what your graph should look like. So, domain and range. Your domain should be all real numbers. Your range always goes with y. We notice that ours starts at -3 and gets greater, so it's going to be y is greater than -3. Notice that your asymptote and your range match, which is good. Lastly, let's do our mental check. Does this make sense? This looks like a decay function. It starts high and ends low. 1/4 is between 0 and 1, so this is a decay function. So that's good. We have a decay function, matches a decay graph. So that tells us that our answer is along the right track, if not correct. So that one was tricky, I know that. It's okay if you had a little bit of difficulty making some of those calculations, but you should be able to do this without the use of a calculator. Next, I would like you to do the next problem. To make it a little easier, I'm going to cross out that 2, so you don't have to do the 2. But I want you to pause the video and try this one on your own, please. Try your best to do it without a calculator. Good luck. Okay, let's see how we did. Our asymptote should have been y equals 5. Your domain should have been all real numbers. And your range should have been y is greater than 5. Looking to our table, your table should have started at 4. If I substitute in 4, I get 6. If I substitute in 5, I get 5 1/3. And if I substitute in 6, I get 5 1/9. When I substitute in 3, I get 8. And when I sorry, that should be an 8. Kind of looks like a 9. When I substitute in 2, I should get 14. Okay, so hopefully you did that. And then finally, with our graph, the asymptote is at y equals 5. Graphing the points we have: 4, 6, 5, 5 1/3, 6, 5 1/9, 3 and 8, and oh, that is definitely not the right point, sorry. 3 and 8, and then 2 and 14 definitely doesn't fit on the graph. Sorry that this one went off a little bit, but this is what you should have gotten. Again, my guess, if you made a mistake, is that you had some trouble substituting some of those numbers in. I'll show you 3 and 2 real quick just to make sure that you figured out how to do those. So substituting in x equals 2, I get 1/3 to the power 2 minus 4 plus 5. This is 1/3 to the negative second plus 5. 1/3 to the negative second means flip, so 3 over 1 becomes positive, plus 5. 3 over 1 squared is 9. 9 plus 5 gives 14. It's a similar idea for 3. To check, does our answer make sense? Again, this looks like a decay function. That's because the graph starts high and it decreases. Our equation has a 1/3 to the power x. 1/3 is between 0 and 1, so this should be a decay function. Hopefully that went well for you. If not, please bring any questions you have to class tomorrow. I have one quick trivia before we go. Do you remember, what did the 7 dwarves in the Snow White movie do for a living? Write down your answer and bring it to class tomorrow. See you tomorrow.